In this video, we're going to quickly describe the definitions of injective and surjective linear transformations. So suppose we're given a linear transformation T from V to W. So V and W can be any vector spaces, but if you like, think of them as Euclidean spaces. So the first definition is of an injective linear transformation. So injective transformations send different vectors to different places. So what that means is that if you take two vectors from your domain, maybe V and W, and they are different vectors, so V is not equal to W, then T of V is not equal to T of W. They end up at a different place. If they started out at different places, they end up at different places. So maps with that property are called either injective or one-to-one. So those two words are going to be used interchangeably. The other definition we want to talk about is what are called surjective or onto linear transformations. And here we want to think about transformations that fill up all of the codomain. So in general, when you apply your map T, your domain was only going to be part of your codomain. So surjective maps are ones where the image is actually the entire codomain. So in this case, we can think about that in symbols as saying that the image of T is actually equal to all of W. So the image of T is always going to be a subspace of W, but when you have a surjective map, it's actually all of W. In following videos, we'll talk about how to actually test if a given linear transformation is injective and or surjective.